some of you might have been there before. So I mainly work with children from sort of 4 to 18. I spend a lot of time with the A-level students and the GCSE students. And we also do some adult learning courses up there as well. And then the other half of my job is quite different from that. I'm a GIS analyst, which is Geographic Information Systems. So that basically means I spend a lot of time on a computer looking at maps and making pretty maps for people. So most of my job has so far been looking at habitat connectivity and how we can calculate that within Surrey and think about how things can move around our landscape. So some of you might have seen me at the AGM talking about that before. But as for today, I've got my pond hat on, so I'm here to talk to you about that. So my background in terms of pond stuff is mainly my university career. So I did my master's in aquatic conservation, ecology and restoration. So I spent a lot of time in Norfolk looking at farmland ponds and how they were restored and basically what's best to do with them for the wider landscape. So it's been an interesting journey, so feel free to ask questions about all of that. But in terms of what we're talking about today, obviously we're talking about ponds and lakes in winter, which is very topical for the moment. Some of you might have seen some ice already on your local ponds this year. It's been a really cold couple of days where I am. So we're going to be talking about, firstly, a more local picture. So thinking about maybe what's going on in your pond, in your garden. Is it going to freeze? What happens if it freezes? And then we're kind of going to segue into a more global picture, thinking more about bigger lakes and the role they play in global climate and what we can actually learn from them in terms of what the climate's been doing over the past, hundreds of thousands of years. So it's going to be a bit of a journey, but hopefully it will make sense and be really interesting for you. And obviously, if you have any questions, feel free to type them in the chat, or you can ask them at the end, whichever you prefer. Obviously, okay, my PowerPoint's not working. Okay, here we go. So sort of the biggest question people seem to want to know the answer to about what's going to happen to their pond in their garden is my pond going to freeze solid? So the short answer is no. Unless you literally have a puddle, it's not going to freeze completely solid. You're just going to get a thin layer of ice on the top. The long answer is a lot more complicated than that, and that's what we're going to be covering in the first part of the talk. So hold on, because it is a bit of a complicated story. So sort of take your minds back to O-level GCSE science when you learn about solids, liquids and gases and how density works with them. So just for a recap, matter tends to exist in one of these three states: solid, liquid or gas. And the molecules in those diagrams there, the little blue circles, are just showing you how sort of the atoms and the molecules are held in each of those three states. So in a solid, they're in a really nice uniform, tight formation. In a liquid, they're a bit more random and further apart. And in a gas, they're just really out there flying around everywhere. So generally, you're moving from a more dense state in a solid to a less dense state in a gas. And generally as well, it's important to remember that heat is what causes that. So your solid will melt into a liquid, your liquid will evaporate into a gas. And so as heat rises, density is decreasing. So remember that for now. And then it gets a little bit more confusing because water actually doesn't follow these rules. And water is actually at its most dense when it's a liquid rather than when it's a solid. So at 4 degrees C, you can see on this graph over here, I don't know if you can see my mouse pointer, but the blue line is at its peak when it's just below 5 degrees C at 4 degrees. So that's actually when water is at its highest density, which means that warm water is less dense than water at 4 degrees C. So anything above 5 degrees C, you can see the line sloping down. But then also, confusingly, water between 0 and 3 degrees C is less dense than this point at 4 degrees C. So cold water can be cold water can be less dense than warmer water, when really warm water can also be less dense than warmer water. So a little bit confusing there. And then it gets even weirder because you can see that there's a kind of cliff edge in the graph here when it transitions from water to ice. So ice has a really, really dramatic decline in density. So ice is always going to be pretty much less dense than liquid water. And that is why ice floats in your drink when you have an ice cube in your drink, because it's less dense than the water below it. And the reason for that is just due to the way that the molecules actually sit in the ice. So you can see in this little diagram down here, the little red circles, which are the H2O, the water, are held apart quite rigidly in the ice, and there's big gaps between them. Whereas in the liquid water, they're quite close together and they're not being held rigidly apart. So in summary, ice is less dense than water by a lot, and water is actually at its most dense at 4 degrees C. So that's important to remember, that sort of magic number of 4 degrees. So hold on to that knowledge for now, and we're going to come back to it in a minute.
Ben, I'm really sorry to interrupt, my lovely. Can you adjust your microphone, because the sound is fluctuating a little bit?
Is that better?
That is better. Sorry, everyone, if you've
No
had
worries.
a sound experience. Ben, I'll order you one of these.
Okay.
We want many more talks from you.
Sophie, would you like me to recap anything if the sound was bad, or?
I will ask if anyone is listening and didn't hear specific items, just send me a message in the chat. And thank you for putting a message in the chat already to let us know about the sound problems. I wasn't quite sure how it was coming across. No, just go for it, Ben. Brilliant presentation. I'm gripped already. Thank you so much.
Sorry about that, everyone. I hope it's better behaved for the rest of the presentation. So where was I? So magic number of 4 degrees C. And now we're going to come back to that in a minute. And first of all, we're just going to look at what is going on with the water in your pond or your lake throughout the year. So where we live in a temperate climate, and we have 4 seasons in our year. So our lakes and our ponds are going to behave in the way I described, but the rest of the world obviously has different climates, and there are different types of lakes that mix in different ways depending on where they are and what the climate's doing. So some lakes stay mixed the whole year round, some never mix at all, and ours tend to follow what the seasons are doing. So I'm just going to walk you through that now. So for the majority of the year, in this case for autumn and for spring, we don't get any stratification in our water. So what stratification is when it separates out into layers. So in autumn and spring, there are no real distinct layers, and everything's mixed up, and it's the same temperature throughout the entire water. We've got wind going across the surface, and for the most part, that's what's causing the mixing of the water, and the temperatures stay fairly uniform throughout the entire pond or lake. The weather isn't hot enough to cause a big difference in the temperature between the water at the top and the bottom of the pond or lake. So that means there isn't a big difference in density, so there's no need for the layers to separate out at this point. So in the summer, it does heat up a little bit, and then because the sun is heating the water, it causes those differences in density. So at the sort of height of the summer, we tend to get 3 levels in our pond, so they have stratified now. At the top, you have an epilimnion, which is the warmest part. Then at the bottom, you have a hypolimnion, which is the colder part. And then in the middle, you have something called the thermocline, which is just the transitional zone between the two, where the temperature flip-flops from warm to cold. So the epilimnion tends to be as deep as the sunlight can penetrate through the water. That water gets warmed up. It's quite warm, so the density decreases, and that's then floating on top of the colder water at the bottom, where the sunlight isn't penetrating so much. It's not warming it up, so it's colder and it stays right at the bottom. And then in winter, it gets a little bit more confusing. So the summer is kind of as we'd expect. The warmer stuff stays on top because it's less dense. So in winter, you start the story with the temperatures are decreasing. The whole water body tends to cool down together because it's just coming out of autumn where the temperatures are all mixed up. And as the temperatures in our air cool, the water is going to cool down further and further and further until the entire pond reaches about the 4 degrees C, that magic number we talked about before. So then the whole water's 4 degrees. Then temperatures drop even further, and we get a thin layer of ice forming on the top of the pond. Like we talked about already, that thin layer of ice is going to stay floating on the top because it has a really, really low density. And then the ice as well, like we talked about, because the molecules are held quite far apart, you get little pockets of air, which helps to insulate the water below and ensure that it doesn't freeze solid and it doesn't drop to quite 0 degrees. So now, because there's no wind getting to the water, because the ice is causing a barrier for that, the water starts to separate out into those different layers again. So the 4 degrees C water sinks right to the bottom of the pond because it's the most dense. And then you sort of get a gradual increase in temperatures moving up from that towards the surface. So it's easier to see in this diagram, where hopefully this summarizes what I've been talking about in case you've got a little bit lost along the way. So the whole pond cools down to 4 degrees in the winter. The ice forms on the top, it freezes over, stops the wind mixing it. And then just like in this blue diagram over here, you can see the 4 degrees sinks to the bottom because it's the densest and coincidentally at this point also the warmest. And then it goes up all the way to 0 degrees C through the water column. The summer, like we talked about before, is the opposite of that. You have the warm water at the top, gradually decreasing in temperature as you move down with your 4 degrees at the bottom, because again, it's still the densest, it's still going to be at the bottom. Obviously, you've also got these addition of these little fish on this diagram, and that's just indicating which part of the water that life is going to be active in at different times of the year. So they follow the warmest water. So in the summer, things are more active at the top of the pond, and in the winter, things are more active at the bottom of the pond. So now we're going to go into a bit more of a detailed breakdown about what that actually means for the wildlife in the pond. So like I said, they've moved down to the bottom of the pond, but they still remain active beneath the surface. So unless you're unlucky, like this water boatman in the picture here, he's got frozen in the ice on the top layer, everything beneath the ice is going to be okay. It's going to be sinking down to the bottom of the pond, following that warmest water. And as long as light can still penetrate through the ice, so there's not a buildup of leaves or snow or anything blocking the light from getting through, the plants in the water are still going to photosynthesize. And that means they're still producing oxygen, and there's still going to be food and oxygen in the water to support the rest of the ecosystem. So the photosynthesis, like any process, slows down in cooler conditions. So it means although the plants are producing oxygen, they're producing less of it because their processes are slowing down. However, nature has a solution for that, because actually all life processes slow down when it's cold. So that means all of the animals, including us, the metabolism works slower as well. So you actually need less oxygen and less food to survive at this time of year in the cooler conditions. So although plants aren't being as productive as they might be in the summer, the animals don't actually need them to be, because they're consuming less resources as well. So I'm just going to go through what different groups of animals that live in the ponds do, because actually it's quite interesting and they all have quite cool little adaptations to survive throughout the year. So we'll start with insects. It's one of my favorite groups. Fantastic picture here of a great diving beetle, which is coincidentally one of my favorite pond creatures. And they mostly need to remain in the water, apart from adult beetles who can breathe terrestrially in the atmospheric oxygen. Most aquatic insects need to stay in the water because they can't survive without it. So lots of them then sink down to the bottom and follow the deeper, warmer water, and they're active in that warm water at the bottom of the pond. Some of them choose to burrow into the mud for a sort of insect hibernation. We call hibernation in insects diapause instead, because it's more of a state of arrested development where literally they freeze everything they're doing. They just stop. And then when conditions improve, they start again. So it's a little bit different to what mammals do, where mammals are not quite stopping all of their life processes during hibernation. They're just doing them quite slowly. Interestingly, insects are triggered by the length of day to go into this state of diapause, not by the temperature. So what that means for them is that it's obviously as the days get shorter, as we go towards the winter, that's what is triggering their hibernation or their diapause. It's not related to the temperature. So obviously, probably we've noticed in our lifetimes that obviously the days still get shorter because we're still going around the sun in the same way, but the temperatures that maybe used to be associated with December or November are probably a bit warmer than they used to be. So we're having a desynchronization between temperature and length of day that's traditionally been associated with our part of the world. And that could cause issues for the sort of life cycle of insects at this point, because there may be, cooler temperatures than they're used to, warmer temperatures than they're used to. So it could cause disruption for them. My PowerPoint's frozen. Okay, there we go. So the next group are the crustaceans. So lots of people think crustaceans are just sort of crabs and lobsters and things like that in the ocean, but actually there are a huge amount of crustaceans in fresh water as well, which are quite small, rather than crabs or lobsters. Things like woodlice are actually crustaceans. Their cousins, the water lice, which you can see a picture of here, are crustaceans as well. And then there's lots of microscopic crustaceans, such as water fleas, that's what the picture is of there, and other sort of relatives of them like ostracods or copepods you might have heard of. So they remain in the water as well. They're not very good at existing outside of it. The water lice and things like freshwater shrimp live at the bottom anyway. They tend to like living in the mud and the sediment at the bottom of the pond. And they have a huge amount of food that's come in from the autumn leaf fall because they're decomposers. So they kind of just continue munching away at their mountain of food from all the autumn leaf fall at the bottom of the pond. They're just a bit slower, like I mentioned, their metabolism slow down as well. The Daphnia, or the water fleas, are quite interesting because they have a really weird life cycle. So you have to bear with me because it's quite a long story. The Daphnia are actually a female-only species while they're in good conditions. So all throughout the summer, the autumn, the spring, there are only female Daphnia, and they reproduce asexually or parthenogenically, which means basically they, with their unfertilized eggs, they just make more female offspring. And then it's only in the winter or in particularly harsh conditions that they start having male offspring. So when temperatures drop and we enter the winter, they lay their winter eggs, or their emergency eggs basically, which have a really hardened shell and are much more able to withstand difficult conditions. So these winter eggs are always male, so the Daphnia lay these eggs at the beginning of winter. Lots of them probably die off over the winter period. And then as they come out of cooler conditions, the winter eggs start to hatch. The males help to then replenish the population through sexual reproduction and give them a bit more of a genetic mix. And then once the population's back to normal, all the males die off and they go back to laying female-only eggs. So that's a really, really strange adaptation, but it's one that exists quite a lot in the microscopic animal world. So that's one way to survive the winter. Oops, I've gone backwards. There we go. So another group, obviously, that we associate with ponds are the amphibians. So newts, frogs, and toads. Some of them do stay in the water and they burrow into the mud at the bottom to hibernate, but lots of them also leave the pond as well to search for somewhere to hibernate on land that is damp but frost-free, most importantly. So some of you might have spotted things hibernating in your gardens already, often under paving slabs, in compost heaps, log piles, sometimes in greenhouses. And they quite like bug hotels as well. So that's always a good addition to your garden. With amphibians, again, we've got a slightly different word for hibernation. So they do brumation. So you can read it on the slide there. And that means that they are hibernating, but it's a much more temporary state than mammals. So on a warm winter's day, frogs and newts might actually wake up and go about their business and then only go back into a hibernating state when temperatures drop again. Whereas for a hibernating mammal, they're just going to sleep through that warmer winter day. They're not going to wake up temporarily. Quite a cool fact is that some frogs have a natural antifreeze in their blood, which means they are sort of extra resistant against difficult conditions in the winter. So that's another cool adaptation that things tend to have. Last group we're going to cover is the fish. So obviously lots of fish migrate for the winter, things that live in rivers like salmon and things like that. But obviously it's not an option if you're a fish that lives in an isolated water body like a lake or a pond that isn't connected to anything else. So much like the other groups, they have a slowed down metabolism during this winter period. They sink down to the bottom and kind of just chill out there until temperatures increase. Their kind of survival strategy for this kind of year is by laying their eggs over the winter. So what this means is if the adults die off due to difficult conditions, fish being that much larger and a bit more complex than some of the other animal groups that we've talked about, tend to require a little bit more oxygen to survive. So what this means is by laying their eggs, even if some of the adults die off, the eggs can then hatch again in the spring and continue the population. Unlike insects, they are dictated by temperatures rather than the length of day. And lots of studies so far have suggested this could impact their reproductive success. So what it means is that short, warm winters are causing females to lay their eggs too soon before they've developed inside them, and it's causing the eggs to hatch too soon as well. So eggs are hatching at lower rates and producing smaller individuals than females would be in a traditional winter. So possibly we're going to have some bad impacts on the fish. So we're going to flip-flop now and go into the more global picture of lakes in winter and what's going on with the ice in them. So lots of lakes around the world have played a really large role in helping scientists establish what has happened in the global climate over hundreds and hundreds of thousands of years. So what you've got a picture of here is, on the left, it's a big ice core drill in the Antarctic. So scientists take these machines and they drill down into the ice underneath the ice sheet. So in the Antarctic and the Arctic, you have things called subglacial lakes, which are lakes that basically exist underneath the big ice sheet. So the scientists are drilling down into those to get what's called an ice core out. In the Antarctic, the longest one of these was nearly 4 kilometers long. So they've drilled down 4 kilometers beneath the ice and got an ice core out that was 4 kilometers long. So these ice cores produce a layer every single year through the precipitation that's falling. So you can just imagine how many years of history we can look at from a 4 kilometer long ice core. It's nearly 500,000 years. So what the picture on the right is showing is taking the ice core back to a lab, they split it up into all those annual layers, and then they analyze their chemical composition to learn about past climates. They also look for any air bubbles that have been trapped in the ice, because those air bubbles are essentially a time capsule of what the atmosphere was like at that point in time. So by looking at those, you can get a very, very accurate picture of what the climate was doing then. So bear with me with the slightly confusing graph, but this is a record of temperature that's been reconstructed from these ice cores. So the graph goes back to 450,000 years ago. The blue line at the top is from the Epica ice core, which is in the North Pole, and the green line below it is from the Vostok ice core, which is in the South Pole. So you can see that at either end of the globe, the same patterns are being recorded in the ice. So that's a good argument in favor that these records are consistent, and so we can really trust them in terms of what they're saying. So what you can see is that the temperature has risen and fallen quite dramatically throughout the Earth's history. And each of these big spikes and drops are when the Earth has gone into big sort of ice ages and then come out of them again. And you can see going towards the present end of the graph, we have obviously got a bit of a dramatic rise in modern times, though not as high as temperatures may be in past interglacial periods, which are the warm bits between the big ice ages. But that doesn't necessarily mean that climate change isn't real, and we'll come on to why that is. So this is a sort of zoomed in version of that end part of that graph. And you can see there's a few different colors going on. So the blue line is what was reconstructed from those ice cores. And then it turns into a black line just down this end. And that black line is the start of observational records, which means from that point in time onwards, it's what we've actually recorded with thermometers. So we know it's true. And then the yellow and orange lines are predictions for the future based on different climate change scenarios. So the yellow line is a slightly more positive climate change scenario, and the red line is a bit more of a pessimistic one. So you can see back to this end of the graph, we've got a big warming as we came out of the last ice age, the most recent one. Temperatures tend to be fairly stable throughout the last 10,000 years, and then it starts to go up again as we enter the modern era. So although these observational records at the moment, you can see the black line isn't actually as high as some of the graph goes previously, but what is different this time is the unprecedented rate at which that line is rising. It's almost vertical, and that is why it's a problem, basically. We won't go too much into climate change because we're talking about lakes today. So lakes that don't exist beneath the North Pole also have lots of interesting things to tell us. So lakes that don't spend their entire year frozen are called Nonglacial lakes, and they get things called varves, which are layers at the bottom of the lake and some ponds as well, which form in annual layers because it's all of the sort of sediment and mud being washed into them, which then settles down at the bottom of the water, and that is what accumulates over time. Like the ice, it forms in annual layers, so it's really easy for scientists to sort of count back through the years and look at what's happened. The pattern with them is that they generally get thicker in warmer years, which means there's thicker layers when the year is warmer, because the lake spends less of the year frozen, so more material is able to wash in. So this graph down here shows us there is a big increase in recent years in the thickness of some varves. So another sort of piece of evidence that our climate is moving towards more warm years, obviously. So again, with lakes around the world, we're noticing a big change in their freeze dates and their thaw dates over the last 200 years. So whilst these graphs are a little bit noisy and messy, I've put the solid black lines on to help you see the general trends that are being shown. So back in 1860, the winter freezing of lakes would happen more in December, but in modern times, it's not really happening till February. In terms of when the lake actually thaws then for the spring, it used to not be until early May or late April. And actually today it's more like early April, late March. So we're seeing a real change in when lakes are freezing and thawing around the world. So what that means, is so far, because of climate change, there are nearly 15,000 lakes around the world that are no longer freezing every winter, that always used to freeze. And you can see by this sort of snazzy graph over here that as climate change increases and different scenarios are applied, more and more lakes are going to stop freezing every winter. So with a 2 degrees C increase in temperature, which we are quite nearly at and is fairly likely we'll get to, 35,000 lakes will no longer freeze. And if we get to 8 degrees C, which is kind of worst case scenario for a lot of models, nearly 250,000 lakes around the world will no longer freeze every winter. And this is taken, a lot of this is taken from observational records. So Lake Suwa in Japan has the oldest record of a freeze thaw date of a lake. So this picture obviously isn't from 1442 because there were no cameras then, but 1442 is the year that their records go back to, because it was a really important part of the monks' rituals to go out onto the ice and do their ceremonies out in the middle of the lake. However, the lake no longer freezes. So after hundreds of years of carrying out these traditions, they're no longer able to, because it doesn't freeze every year anymore and it wouldn't be safe for them to walk out on it. So there's these humanitarian and kind of cultural aspects of this as well, other than just the environmental ones. So kind of recapping, I've talked about lakes aren't going to freeze anymore. They're not freezing for as long all around the world. And we talked about already that there's going to be a huge life cycle desynchronization for a lot of different groups of animals. We talked about insects, amphibians, fish. And a really good quote that I found when I was researching this is that ice cover basically acts as a reset for lakes in winter. So the fact that these lakes are no longer experiencing that is what's going to maybe cause some really big problems for their wildlife going forward. Because all of these creatures that live in them have adapted to the winter, as we've seen in our earlier slides. Some of them have quite complicated adaptations to surviving in a frozen lake. But if these lakes are no longer freezing, what's going to happen to them? Well, firstly, the increase in temperatures is going to cause an increase in algal blooms. So that's a cool issue called eutrophication that some of you might have come across before. When those algal blooms sort of die off all in one go, they rapidly decrease the oxygen in the water, and it can cause big fish kills. We've seen that in the UK, in the Norfolk Broads, where that's happened, and generally very bad for the pond or lake if that happens. We talked about life cycle desynchronization already. You're also going to have disrupted regional water cycles. So if the region is usually somewhere where lots of water is held in ice and it's no longer that way, there's potential for more flooding, more runoff on the land, more erosion, all kinds of things like that that are going to be detrimental for humans as well as the environment. And then linking back to the monks, there's going to be a reduction in ice-related ecosystem services. So ecosystem services is just a word to describe all of the things that the environment does for us, whether that's providing a resource like food, but also providing maybe somewhere that it's nice to go for recreation, or somewhere that we can go for education or something like that. So certain cultures, such as like the Inuit people and other native peoples in Canada, and even in the sort of Slavic countries in Europe, have whole parts of their culture built around the ice, whether that's ice fishing or ice sledding, or just using it as a valuable economic resource, they're going to see some real trouble if their sort of local areas aren't freezing the way they used to, and they're going to have to change the way they do things to survive. And lastly, we're going to see a shift in species ranges. So what that means is that because things are adapted to a certain way of life, they are not going to be able to evolve new adaptations very quickly. So it's easier for them to just move further north to a place that is now more mimicking their natural conditions. So what that might mean for things that are stuck in isolated water bodies, such as a pond, is that they can't move. If you're a fish in a pond that's not connected to a river, you are not going to be able to migrate north, and the population might go extinct. And what it also means is that species that are better suited to the new result of climate change conditions are going to move north and start replacing the species that we normally see. And these invaders are going to cause issues for them as well through competition of resources and other things. So to end on a more positive note, what can we do about all of this doom and gloom? Sorry. And what we can do is try and make space for nature in our gardens and homes, basically. We're not going to snap our fingers and stop all of the global corporations emitting pollution overnight, but we can make space for nature and try and facilitate some of the effects that they might be feeling in the coming years. So we can provide high quality habitat for them in our gardens. We can provide them with safe spaces to hibernate in the winter, where they're not going to be vulnerable to predation, especially if they might be hibernating for a different length of time. And most importantly, we're going to be providing connections in the landscape. By more people having spaces like ponds in their gardens, you're going to be providing stepping stones for a lot of creatures if they do need to migrate north to escape changing conditions. Obviously, not everything can do that, but a lot of insects, water birds, and even some amphibians will migrate between ponds if they're close enough. So on that note, please build ponds in your garden. They'd be great for the local wildlife. And thank you for listening.
Thank you so much, Ben. That was absolutely fascinating. Made me quite cold looking at some of the colder images. Does anyone have any questions? Oh, I see a question that's just come in. I have a small pond near trees. Should I clear the leaves off the surface? That's a great question.
So if it's in the autumn, you probably do want some leaves to enter the pond because they provide an important food source for the animals that are decomposers down at the bottom. Obviously, you don't want too many to a point where it sort of overwhelms the pond. And in winter, if the pond has frozen over, then you absolutely want to clear the leaves off of the surface. Sorry, I've talked too much. Clear the leaves off of the surface so that the light can still get through the ice and help the plants continue photosynthesis. So I would say in moderation, clear them out because you don't want to be removing wildlife with them. And they are an important part of the sort of yearly cycle in terms of a nutrient input to the pond.
Brilliant. Thank you very much. If anyone has any questions, do feel free to, oh, I can see lots of questions coming in now, to wave frantically at the screen. I will try and maximize my screen so I can see all your lovely faces. Right, we have one question coming in from Beverly. What proportion of fish eggs that are laid in winter are lost? That's an excellent question.
It's something that scientists are still looking into, as far as I know, and it really depends between the species and where they are and how much difference in temperature they're experiencing. So I'm not sure of the exact proportions, but essentially what studies have shown so far is that a significantly lower proportion will survive to the extent where it is going to have a big impact on the overall population of fish. So really, really good question. And there's definitely maybe some more research to be done there on my part, but if you're interested, you could definitely look it up and probably get some more detailed numbers out of the actual papers themselves.
Fabulous. Thank you, Ben. Again, I'm getting questions through chat, which is fantastic. If you would like to ask a question in person, do feel free to sort of unmute yourself and then mute yourself after you've asked a question or turn your camera on. Right, bear with me 1 second. Right, next question is, let me just scroll down. How deep should our pond be? We are just digging it. Well, that's a great time to join this coffee morning this morning, isn't it? It's about 10 foot by 10 foot. Wow, that sounds fantastic. I wish I had enough garden to fit that in. Ben, over to you for that question.
Yeah, that is a really good question. So I guess there isn't necessarily a right answer because ponds come in all shapes and sizes. And that's actually a good thing because different shapes and sizes of pond will create habitat for different kinds of species and different kinds of plants. So actually it's better to have a variety across the landscape rather than everyone's pond being exactly the same. So a 10 by 10 one is fantastic and that's going to provide some really, really good habitat. And what I would suggest is creating a more gradiated depth. So have a deeper part out in the middle and have some shallower areas at the edges, because what that will mean is that different communities of plants and animals will exist in different parts of your pond. So you'll get more marginal plants growing in the shallower edges, and you'll get more open water plants growing in the middle. And then obviously the animals that are associated with those different groups will follow.
Fantastic. And on that, actually, I'd just like to mention that our adult education team do lots of amazing courses, and I know they regularly do sort of courses on and sort of other things on ponds. So if you are interested in creating sort of the most sustainable wildlife friendly garden, do check out our adult learning courses to sign up. I know last year they did quite a few different ones. The one that specialized on ponds, one that specialized in sort of bug hotels and stuff like that. So lots to look at. Right, I have another question here. Should I break the ice in my pond when it freezes over, or will the ice offer more protection from the temperature drop? That's a brilliant question. Thank you.
Yeah, so like we were talking about, a lot of the animals in your pond have adapted over millions of years, really, really specific adaptations to survive under a layer of ice because, you know, historically in Britain, our ponds have always frozen in winter. It's just because our temperature is that way in the winter. So whilst some people might choose to break their ice if they have more, you know, like koi carp or ornamental fish in their pond that are a bit more difficult and expensive to keep, if you've just got a wildlife pond, I would suggest leaving it the way it is because sometimes breaking the ice can cause more problems than just leaving it there.
Brilliant. Thank you very much, Ben. Right, I have no more questions at the moment. Just a couple of messages saying thank you for answering your questions already so brilliantly, or everyone's questions so brilliantly. Again, if anyone has any questions, feel free to wave at the screen or send a message on the chat function. Right, someone said, oh no, someone's having computer issues. Yes, there will be a recording and we will put that on our online talk pages. There are also previous recordings of previous coffee mornings and evening talks, if you would like to view them as well. Just bear with me because it takes feels like a decade for it to upload from my computer.
So hopefully Sophie might be able to do some computer magic and increase the volume for the first part if it was too quiet for people.
I'm not sure I'm that clever. I'm still learning. It's been coronavirus has certainly helped with the speed up of knowledge on technology for me, intentionally or unintentionally. Right, we've got another few questions. Oh, that's a lovely question. Does Ben have any more talks planned next year? Yes, I'm absolutely nabbing him for lots of talks next year. He said he was keen yesterday. Hopefully he'll be still keen after this. So yes, Ben, what would you like to talk about next year?
Well, I'm glad there's a demand. Well, I've talked about a few things already for the Trust. So I've talked about the history of climate change over sort of really, really big timescales, like the beginning of the Earth timescales, which is an interesting one, but a bit heavy going. I've done courses on GIS, which is if you're a more computer savvy person, those are quite good to help you understand how, if you wanted to create maps and things like that for any species recording you do. I've done a course on freshwater beetles, so like a more identification kind of course, because I like them a lot. Yeah, Sophie, I don't mind anything, that as long as I know about it.
All right, you all saw that. We've got that recorded. That's his promise. Right, we have a few more questions coming in. Someone says, I've got a leak in the pond. What is the best time of year to empty it to repair it? That's a brilliant question.
Yeah, that's a tricky one. So obviously it probably depends what kind of pond you have. If it's like a natural clay lined one or it's an artificial lining, it's going to be more difficult or easier to repair. But generally, September is the best time of year to do work on your pond, because the water level in theory is at its lowest after a warm summer. And most of the inhabitants of the pond have got their summer life cycle out the way, which is usually quite an important part. So when we do pond restorations, so like in my work over in Norfolk at university, September is the best time of year to do it, because although it's never completely undisruptive to do it, it seems to be the least disruptive time of year to do big work to a water body. And there are things like precautions you can take. You can try and keep little buckets full of your water with the plants in them, try and maintain some of your insects in those buckets while you do the work, and try and put the same water back in afterwards. So I would say try and take some precautions, but obviously if it's leaking, then you need to sort that out.
Brilliant. Thank you. Right, lots of questions coming in. Should I collect some frogs for from my neighbour's garden to introduce them to my pond, or just hope they will find their own way there?
Well, in an ideal world, they would find their own way there. So it might be an interesting thing to have a look at how many barriers there are between your neighbour's garden and yours. So are there any little holes in your fence that might have been cut for hedgehogs or something like that? Is there actually a way for the frogs to get from their garden to your garden, or is there just a big fence in the way that they can't pass over? Yes, you could bring them yourself, but they'll be much happier if they get there on their own. And in the process of facilitating them getting there on their own, you'll probably be opening up all sorts of doorways for hedgehogs and other animals to cross over between your gardens and help them spread throughout the landscape.
Wonderful. Right, the next question I have is, we've set up a Hoverfly lagoon this year. Brilliant, I love them. What happens to it during the winter? It's very small. Is it likely to have life in it now?
That is a really good question. Hoverflies are a really exciting group because they're very under-recorded. So it's nice that people are doing things for them. I don't claim to be an expert about hoverflies, but from what I know, lots of flies have relatively short life cycles. So it may be the case that having your lagoon over the winter is okay, and you don't need to worry too much about stopping it from freezing. But it might be one worth looking up or asking a more hoverfly expert person about, because lots of hoverflies do have aquatic larvae, and I didn't cover them too much in my talk, and they probably survive okay in a deeper pond. But if you've only got a little lagoon that's maybe not much deeper than a bird bath, it might not be great. But equally, it is a thing to have a hoverfly lagoon, so they must have thought about it.
Brilliant. Right, quite a few more questions coming. This is very good. Right, when's the best time to clean a pond? Early in the year or later?
Yeah, I think, like I said in my other answer, September is really the best time of year to do something like that, because as far as we can tell at the moment, it's the least disruptive time of year to all of your creatures that live in there, and you've sort of going to have the least detrimental impact by doing it then.
Brilliant. And we had another question from someone else as well, actually, referring to leaves again, and the best time of years for the best time of the year to do that as well. I assume that's the same.
Yeah.
Brilliant. So September, that's
yeah,
a date
in your
diaries. Yeah, absolutely. Elizabeth, bless you. You said you've got hedgehog holes, so you're going to put a sign up for frogs. I love that.
Oh, brilliant.
Brilliant. Wonderful. And then what can I do to help the frog spawn develop? I have several batches each year, but the tadpoles never survive. I have loads of newts, 9 common and crested, common and crested, and dragonfly larvae, and the pond is really small. Wow, that's a significant amount of wildlife you have in your pond. That's amazing.
Yeah, that's an interesting one, because I think a lot of people have these kind of debates of like, oh, my fish are going to eat my frog spawn, or I can't have fish and newts together, or I can't have frogs and newts together. But tadpoles are, for a lack of a better word, they are just fodder for everything else in the pond. They are a really important food source for a lot of the other animals there, especially the dragonfly larvae. So the reason that frogs and toads have so many young is because they don't actually put a lot of effort in as parents. They kind of just go with the frog spawn and hope for the best. Whereas newts are much better parents in the sense that they actually individually roll each egg in a leaf to protect it. So it may be that in your fairly small pond, the newts are just doing a bit better through their better parenting strategies and ensuring a better survival rate, whereas the tadpoles are just becoming food for everyone else. But if the frogs are there again the next year, it obviously shows that some of them are making it. So I wouldn't worry too much.
Yeah, it sounds like your pond's doing really well. That's absolutely fantastic. I have no more questions at the moment, unless anyone would like to sort of throw in a last minute question, or actually ask the question in person. You are more than welcome.
Can I ask if grass snakes do grass snakes use ponds?
Yeah, they do. They are.
How does their life cycle work?
I don't know too much about their life cycle, but they do hang out quite a lot in water. So they swim through water. I think they feed in water. They have their young on land, as far as I'm aware, because I've seen lots of them under reptile tins and stuff like that, neighboring ponds. But grass snakes are a wetland animal, so they do need water. They do need, and lots of people see them in their garden ponds, actually. So I'm pretty sure it's not necessarily where they have their young, but is where they do a lot of their feeding.
Brilliant. Thank you, Janice.
And I have seen the eggs. I've seen that they lay eggs, don't they? I've seen the eggs, but I didn't know how they use the water. Thank you.
No worries.
Fantastic. Right, we have a couple more questions that have come in via chat. Do frogs and toads require different conditions? That's a brilliant question. I'd love to know the answer to that.
I'm gonna say no. I could be wrong, but they are fairly similar animals in terms of their biology, and obviously both the species that we have naturally here have all evolved to survive in the same conditions. So they both do typically similar things. They both tend to leave the ponds in winter, find somewhere frost-free to hibernate, and then the males head back early in the spring to get in the water for mating and such. So I would say probably frogs and toads are pretty similar in terms of the conditions that they require. And if your garden is suitable for one, it's probably suitable for the other.
Brilliant. Thank you. And the last question I've got in at the moment is, do any SWT managed pond sites use cameras to monitor wildlife visits to the pond?
That is a really good question. I don't know about most sites. I know we have quite a lot of camera traps up at our educational reserves, and mostly we're looking at things like badgers and stuff like that. But I think there are a few pointing towards the pond. So I don't think we've seen anything massively exciting to report on, but we have caught grass snakes and things like that. We've obviously seen larger mammals going to drink from the ponds. But in terms of monitoring water bodies, camera traps aren't always the best thing. I mean, I know camera traps are obviously important if you're surveying for something like otters or larger mammals. So they have been used for that, but obviously people also look at poo, basically. So they will just go and look at where the otters have pooed to track them as well. But a lot of freshwater monitoring is actually more about the plants and the invertebrates, because they're really good indicators of what's going on a larger scale, because they're much more reactive to the conditions in the water. So when professional water people are monitoring the sort of biological health of a water body, they'll mainly do a plant survey and then an invertebrate survey as well.
Brilliant. Right, I have no more questions at the moment. Elizabeth says, thank you, fab answer.
I think there's someone
Claire.
waving.
Hello, Claire. Would you like to unmute yourself?
Hi there.
Hello, everyone.
Thanks for answering us about our very exciting project that we're my husband, to be fair, is mostly digging in the garden as we speak. So it's been really, really interesting to hear about ponds and lakes generally. So we're hoping that we're going to be able to start filling it in the next couple of weeks. We are going to use a liner, although actually he is digging into clay at the moment and it is actually filling up at the bottom. But yeah, anyway, we've got a liner, so I think we'll probably stick with that. So once it's filled up, we're obviously going to try and plant it with the right plants in the spring. And then do we just wait and hope that things start colonizing and arriving?
Yeah, and they will. It takes time. I have a pond as well that I sort of set up last year. And I was a little bit sad in the first year that there wasn't a lot of stuff there. But actually, having left it for a year, it's amazing what's shown up, even though I don't think I'm too near any other ponds. So the main thing I would say in terms of planting it up is just be really careful about where you get your plants from. Lots of garden centres still sneakily sell invasive species, which are actually illegal under sort of fake names, basically, because people have historically had lots of them because they're ornamental and stuff like that and they look nice. But so just make sure you're getting your plants from a more reputable, eco-friendly kind of place, and make sure, just do a quick Google of the name on the plant and check it's a native species before you put it in. So all kinds of things like water mint is great. Iris is great in terms of stuff for deeper water, things like Potamogeton, which are our native pond weeds. Water milfoil or myriophyllum is another really good one for oxygenating the water. Try and avoid Elodia or Canadian waterweed because that's a very commonly
I need you to write these down.
I'll make Sophie send a list.
Well, it's the ones to avoid particularly would be really helpful.
Yeah. So the ones to 100% avoid, basically anything with Crustacea in the name, because that Crustacea helmsii is New Zealand pygmyweed, which is one of the most difficult to get rid of invasive species. And lots of garden centres sell it as Crustacea something else, even though it's that. So definitely avoid that one. Avoid Elodia if you can, which is Canadian waterweed. Lots of garden centres sell that as a really good oxygenating plant, but it is also non-native and it's very invasive as well. Parrot's feather, I'm not quite sure if they can even legally sell that now, but that's another nasty invasive one. Himalayan balsam is a nasty invasive one for the edges. So those would be the main ones to avoid.
Okay, thank you very much. Thank you. It's very helpful. It's very exciting.
Yeah, good luck with it.
And post pictures on social media as well, because we'd love to see it once it's established. It's really exciting. I believe there is a Facebook group, Surrey Wildlife Gardening. I can't remember the exact term.
Yeah.
If you go onto Facebook, there's lots of people that sort of share their tips and ideas and their fabulous photographs of their sort of visitors to their new ponds. So that's very exciting. Sorry, Claire Courtier, would you like to ask a question?
I think Ben's that's okay. Ben, you've just answered the question I was going to ask about which plants you recommended anyway, so that's great, thank you. But now might just be quite a good chance to mention our Wildlife Gardening Awards as well for the Trust. And so if this is something that the Trust does every year, and anybody with a garden, a small space, an allotment, community groups, anybody at all can apply, put forward for the Wildlife Gardening Awards. And and you can then we have winners each year for gold, silver and bronze as well. So have a look on our website. I believe there is more information on there. And I think we do these at the end of each summer. So it is worth having a look at the Wildlife Gardening Awards.
Yeah, and I don't know if you'll still be doing it this year, but in previous years, there's been quite an exciting ceremony, for lack of a better word, where people get their awards And it usually involves a nice talk and maybe an activity. Like one year we did pond dipping for the winners at Narwood, which was good fun. So it's worth doing.
Definitely. Thank you for that, Claire. That was a brilliant idea to promote that. It's really, really exciting awards. And hope to see some of your entries this year. That would be wonderful. Right, I don't have any more questions on chat. So I'm going to sort of draw this meeting to a close. I really hope you enjoyed our coffee mornings. The whole purpose of our coffee mornings are to give us opportunity to share our love of wildlife and our questions and just generally sort of have a chat while we can't do it in person. So the hope is that this will continue. I have just been setting up quite a few more coffee mornings and online talks. So do go to our online talks page. There are recordings as well from previous ones. Ben is definitely down to doing talks next year. We have a talk from David Lindo, the Urban Birder, in January, so book a space for that. And next week is Encounters with Owls with our lovely Ken Ancorn, who's been with Surrey Wildlife Trust forever, and he's hugely knowledgeable. And there's lots more activities planned online. So do sign up, and thank you so much, everyone, for attending, and thank you for your fabulous questions.
Yeah, thank you very much.
It's been great.
It was really nice to meet you all. And obviously, if you do have any questions or thoughts or anything, thank you for the claps. Please do email Sophie, and I'm happy to advise on ponds or anything I can try. So, if you have any questions, please do feel free to email.
Lovely to see you all. Thank you, Claire, for being my co-host and agreeing to do the coffee morning next week. I actually miss these things now. It's kind of almost, I feel I would love to do it weekly. I just don't have the time. I'm so sorry, everyone. So hope to see you very soon, and enjoy the rest of your week. Bye, everybody.
Bye-bye, guys. Thank you.
Thanks very much. Bye.